Today's lecture is on eggs. We'll be talking about the structure of eggs, safety, and grading. We're going to start by talking a bit about the structure and composition of an egg. And as you can see on the slide here, about 75% of that egg, the egg weight is water, 12% is protein, and 10% is fat. And eggs are a familiar enough food that we all know that there are two major components: the egg white, which makes up the majority of the weight of the egg. Egg white is primarily protein, and the yolk, which is the yellow part, and that is where you find virtually all of the fat in the egg. The interesting thing about eggs is, and as we go through this lecture, we're going to find that eggs are extremely versatile and they do a lot of different things in food. And one of the reasons that they're so versatile is because the egg yolk and the egg white are extremely different in chemical composition from each other. Even though they come neatly packaged together, there are a tremendous amount of things that they can do when they're mixed together, both the egg white and the egg yolk. But there are other things that they can do separately. So if you've ever had a recipe where you've separated the egg whites from the egg yolks and done different things with the egg whites and then other things with the egg yolk, there are all sorts of other things that those two components are specifically and specially designed for. And so it's a really, really unique food product. And one of the things about eggs is, if you look at French cooking, the French love eggs, and they do all kinds of things with eggs, and they take advantage of that great versatility. If you've ever seen the chef's hats, the traditional chef hat that has all of the pleats in it, the chef hat actually has a name. It's called a toque, T-O-Q-U-E, and the toque traditionally has 101 pleats in it, and those are used to designate all the different ways that the chef can cook eggs. So the egg is pretty humble, but it is tremendously versatile and a really neat ingredient. So let's look a little bit at the structure of eggs, and I think that most of us probably haven't thought a whole lot about the actual anatomical structure of an egg, but there's quite a lot of things going on in there besides just the egg yolk and the egg white. So we're going to take a little bit of a closer look at what exactly is going on inside the egg. There are 5 major components that we see here. Of course, the yolk is the big yellow part in the center, and then the egg white. The egg white, as I said, is made up primarily of protein, and we're going to talk a little bit more in depth during this lecture about the quality of the white. If you take a raw egg and you crack it onto a plate, one of the things that you're going to notice about the egg white is that some of the egg white is sort of runny and very almost watery in consistency. And the other part of the white is almost jelly-like. If you really look at an egg, you'll see sort of a jelly-like egg white that is around the yolk itself, and then farther out there's kind of this watery white. And as we'll see as we go through our lecture, how much of the thicker jellied white to the watery white really can tell us how old the egg is. It also affects how it performs in certain recipes. The egg white, the actual term for egg white, is called albumin, and you see the word on there, albumin. That is the correct term for egg whites. Now, on the inside of the egg, there's all sorts of structures that keep the egg yolk anchored in the center of the egg, and that's really important because if the egg yolk was not anchored on the inside of the egg, it would roll around a lot, and you would end up with a broken egg yolk all over the inside of the egg white. And so you see there's a whole series of membranes and linings and all sorts of things in and around that egg yolk that are specially designed to hold it right in the center of the egg, really protecting it. Of course, we are familiar with the shell, but just on the inside of the shell are membranes that are all over the inside of the shell membranes. And if you've ever hard boiled an egg and then peeled it, sometimes you might see remnants of this very thin sort of skin that comes off the outside of the hard boiled white, and those are those shell membranes. There is an air cell. If you look at the top of the picture there, you'll see an air cell, and that's something that is very small in a very fresh egg, and it gets larger as the egg ages. We're going to talk more about that air cell in a bit, but it's sort of a pocketing between the egg white and the shell membranes. Around the yolk itself, there's something called the vitelline membrane, and again, that encases the entire egg yolk, and at either end, that vitelline membrane is anchored at the top and the bottom of that egg by something called a chalaza. If you look at the word on the bottom, you'll see the word, it's C-H-A-L-A-Z-A. A lot of people want to pronounce that chalaza and those sorts of things. It's actually a chalaza is what it's called. And it's when you may have noticed it when you crack an egg and you see sort of this sort of thick kind of jellied whites on the end. Some people like to take those off. They're attached to the egg yolk membrane, that vitelline membrane. Some people take them out when they're cooking. Honestly, for the most part, it doesn't really make much of a difference whether you leave it in or take it out, unless you're working on something that requires, an absolute smoothness in texture, like maybe a fine custard or something like that. It doesn't matter one way or another if you leave that in or not. But that thickened white that you see attached to the yolk sometimes, its whole job is to just anchor that vitelline membrane and the encased yolk to the top and the bottom of the egg, again, to keep it from moving around too much. On the bottom of the slide where the albumin is, again, the egg white, you see the outer thin, outer thick, inner thin, inner thick. We're going to talk a little bit more about egg whites as we go along. So the shell membranes we've talked about, the air cell we've talked a little bit about, and then of course the shell. So let's move on. We're going to talk about all of these parts again in more depth as we go through. So as we've talked about, the yolk is roughly 1/3 of the egg's weight. The color and the flavor of the yolk depends on the hen's diet. Hens eat different things, and if you've ever had the experience of eating eggs that have come from a farmer's market or from hens that just forage in the wild, you may find that the yolks many times are a much deeper yellow or yellow-orange color because they're just feeding on whatever they're foraging. Commercially produced eggs tend to have very similar colors, that sort of sunny yellow color. And again, that's because commercially raised hens are pretty much eating the same type of diet, so it's actually quite uniform. Some people who normally eat commercial eggs are kind of startled sometimes about the color of the yolk, in buying a free feeding hen's eggs, because the colors are actually quite different. The actual reason that the yolk exists is that it is a nutritive source for the growing chick. So if that hen's egg is fertilized, the egg white is actually what turns into the chicken, and the yolk is there to sustain the chick until it's ready to hatch. The egg white, as we've talked about, is also known as the albumen. Egg white is actually pretty interesting stuff, and it's funny to talk about eggs that way because they're so common and we all know what eggs are, and we don't on the surface maybe think that they're terribly special, but as I talked about earlier, eggs are really, really complex food sources. The egg white itself, even though it all looks the same, is actually made up of many, many different types of proteins that all have different roles to play. Many of those proteins that are in the egg white are actually enzymes, and we've talked a little bit about enzymes. Enzymes, again, are proteins that are designed to do any number of things. In the case of the eggs, they are protective, and what they do is they actually protect the interior of the egg from contamination from bacteria. So if a bacteria or something foreign was introduced into that egg, one of the roles of the protein in that egg white is to kill it or neutralize it. Unless the hen has an internal infection, like a salmonella infection in one of her ovaries, the inside of an egg is very sterile. There's really no bacteria or anything growing in there because of that enzyme protection. We talked about how egg whites have thick and thin types. So again, that's that jelly, that jellied sort of white that you see around the egg white, or I'm sorry, the egg yolk, is referred to as thick egg white, and then the watery part on the outer part of the edges of a cracked egg, that is the thin type of egg white. And we're going to talk a little bit more about that farther into the lecture because the amount of thick to thin actually changes with the age of the egg. The egg shell is very porous, and that may seem sort of strange because when you think of porous, you think of, well, why isn't the egg white leaking out then? The pores that are in egg shells are extremely small, so much smaller than would allow the egg white to run out. But there's a free exchange of gas, of air, that goes on back and forth through the shell itself. And of course, the inside of the shell is protected by not only the whole system of membranes, but also that enzymatic protection from the specialized proteins in the egg whites. One of the things that I think is a persistent myth about eggs is that brown eggs are somehow more healthy and nutritious than white eggs. And really, that's not true at all. The color of the shell has more to do with the genetic background of the chicken than any nutrient content. So different birds make different colored eggs, and so if you have hens that happen to make brown eggs, they make brown eggs. Hens that make white eggs, they make white eggs. In terms of major significant nutrition differences, there really are none between white and brown eggs. So building on what we just talked about with the egg white, I talked a little bit about this in the previous slide, but the caliciferous layer, try to say caliciferous 10 times fast, is a mixture of thin and thick egg white, particularly the thick layer that gives support to the vitelline membrane, which of course, as I just said, holds that yolk in place. So you can take a look at this structure here. You have the caliciferous layer, thick white, just around the vitelline membrane, and the yolk coming farther out. You've got some thin egg white going on there, and then another layer of thick, and then a little bit more of the outer thin layer in the albumin, and then of course the shell membranes just on the inner side of the shell. So eggs are pretty complicated things. One of the things that I hear about eggs, sometimes people will say, well, I don't want to eat eggs because I'm eating dead baby chickens. And what I have to say to that is that it's not a dead baby chicken until it is a fertilized egg. One of the things that you see on this diagram is something called the germinal disc. If you look on the yolk, you'll see a small round structure called the germinal disc. And it's hard to see on a fresh egg. You can find it if you're looking for it, but if you crack an egg and you look at the surface of the yolk, sometimes you'll see a very, very small white dot somewhere on the yolk, and that is the germinal disc. And what it tells you is whether or not that egg has been fertilized. In an unfertilized egg, that germinal disc is just a small white dot. It means it hasn't been fertilized, it's not a chicken, it's just protein and fat encased in a shell. If that egg has been fertilized, that germinal disc is no longer white, but it is actually sort of it's a darker color, it's darker than that typical white disc would be, like a brownish sort of color. That indicates that that egg has in fact been fertilized. And that's really only a problem in eggs that you might get from a private breeder, maybe somebody who has their own chickens, or maybe if you have your own chickens. Of course, there may be a possibility that those eggs are fertilized. In commercially produced eggs, you rarely find a fertilized egg because the way that eggs are raised commercially, the way hens are raised commercially that are producing eggs, they're never really given a chance to be fertilized. And as we'll see later in the lecture, the eggs are actually examined internally by a process called candling, and it helps determine if that germinal disc is a darker color. If it is, it's actually removed from the supply and it never makes it out to the store. So it would be a very rare situation where you would find a fertilized egg in a commercially produced package that you would get at the grocery store. We already talked a little bit about the chalaza, which is again just part of the structure to anchor that yolk on the inside of the egg. So let's take a look at how to identify fresh versus deteriorated eggs. Deteriorated just simply means that it is an older egg. It maybe has not gone bad, but it is not, the freshest egg that is available. If you took two eggs, one egg that was fresh, very, very fresh, very far from its expiration date, and you took another egg that's maybe been sitting around for a few weeks, you're going to find a few differences between the two. As far as the appearance, the outer appearance of the egg, it's going to be pretty much the same thing. But once you crack the egg, you're going to notice some differences. So let's talk about the fresh egg first. A fresh egg, if you take it and you crack it, and you crack it very gently onto a plate, and you look at it, what you're going to notice is, first of all, the egg yolk and the thick egg white actually stand really pretty tall. They don't spread out very much. So it has a higher profile if you're looking at it. They're standing really pretty tall. The yolk is very firm. It's not really spread out on the egg. It's just sort of it's almost like a bubble. It's very, very high. And I'll have some drawings of that in a few slides and you can take a look at it. In a fresh egg, you're also going to find a much larger proportion of thick egg white than thin egg white. So there's going to be a little bit of watery egg white around the edges, but the majority of that egg white is going to be that jelly-like stuff. And again, it's going to be standing very tall. Usually the flavor of a fresh egg is much better than one that has deteriorated. It tastes fresher, it tastes more like true egg. And if we were to test the acid-base balance, we would find that the yolk of a fresh egg is very, very slightly acidic, with a pH of about 6.0 to 6.2. Remember, neutral is 7. If we compare this to a deteriorated egg, what we would find is if we took an egg that was a little older, cracked it onto that same plate, what would happen is the yolk and the white would not be standing quite so tall. It actually would spread a little bit. And there would be a lot more wateriness going on. There's going to be a lot more thin white than thick white. That thick white has deteriorated, it's lost a lot of its jelly-like consistency, and it's become more watery. And what happens is that, as you see in the next point here, the yolk takes up extra water. So that wateriness is, the jellied egg white is breaking down, it's becoming more watery. The yolk takes up some of that extra water, and what happens is the vitelline membrane that holds that egg yolk in place, it's stretched and swelled and stressed a bit. So the egg yolk actually will break a lot easier than in a fresher egg. A deteriorated egg is not going to have as much of a true fresh egg taste as a fresher egg. The other thing about eggs, because that shell is very porous, eggs are much more likely to have absorbed other flavors in your refrigerator. So if you've stored them in the refrigerator and you have something in there that's especially fragrant, like onions, or in my case, a couple of years ago I had a refrigerator full of Dungeness crab, and found that after a while the eggs that I had in the refrigerator, when I went to cook them, they had sort of a faint crab taste to them, so which I suppose might work in some situations, but for what I was using the eggs for, I didn't really want crab flavor in them. So they're very good at absorbing the odors and flavors from the storage environment. And there's also an increased alkalinity for both the egg white and the egg yolk. And as we're going to find out, there are some food preparation implications for that. Because remember, cooking is chemistry, and so if the pH is off for an ingredient, that can conceivably affect whatever it is that you're trying to cook. We're going to switch gears a little bit. We're going to talk about egg quality, grading, and inspection. So these are the different grades of eggs. We have a AA grade, an A grade, and a B grade. And the AA grade is the highest grade, and this really sort of illustrates what I was talking about with the fresh versus the deteriorated egg. If you look at the AA grade egg, you'll see that the description is, it will stand up tall, the yolk is firm, and the area covered by the white is small. And the reason it's small is because there's a lot of thick egg white. Thick egg white does not spread very much. There is a large proportion of thick white to thin white. So if you look at that top picture, you'll see that on the outer part there is some watery white, but immediately surrounding the yolk there's this quite a bit of nice jellied stuff going on. The drawing shows you that tall profile, and the bottom it shows how that egg cooks up as a poach. It's very compact, which is what you want. If you're doing a poached egg, you want something that's very compact. You don't want it spread all over the place. The second picture, grade A, you're going to see that it still also covers a relatively small area. There's still quite a bit of thick egg white compared to the watery, the thin egg white. The yolk is still very round. It's still tall, not quite as tall as the AA. And the bottom picture is the poach there, and you'll see that it's still pretty compact, but it's spread a little bit more than the AA grade egg. And the final is the grade B egg, and you'll notice that it's spread out quite a bit more. That thick egg white has deteriorated more, has turned more watery. You don't have quite as much high quality thick egg white as there was. The yolk is a little bit more stretched out because it's absorbed extra water. If you look at the drawing, you see that it's got a very flat profile. And then if you look at the bottom, this is what that egg looks like poached. It's kind of sloppy looking, it's all over the place. It's not going to work quite as well in an Egg Benedict recipe as the grade AA would work. Okay, grade B eggs are generally not sold in the grocery store as shell eggs. Most often you'll find this grade, I mean, they're perfectly safe to eat and wholesome, they just don't perform quite as well if you're using them as shell eggs. So often these eggs are put into liquid egg mixes like egg beaters, or they're dehydrated and put as egg powder into something like a pancake mix or something along those lines, or they are pre-scrambled and maybe put together as some sort of a frozen meal or something like that. So that's really how those eggs get used. Howe units, and that's how you pronounce that, H-A-U-G-H, it's Howe. Howe units are a way that eggs can be evaluated in the laboratory to determine what their grade is. The grade and the freshness. So as we talked about, the very fresh egg is going to be standing very high and tall in profile. And what Howe does is the Howe units measure how tall. So as you can see in the picture here, the egg is cracked onto a platform and then it's measured as to how tall it's standing. And it is just a measure of how fresh and the quality of that particular batch of eggs. As far as inspection goes, the Egg Product Inspection Act of 1970 requires that egg processing plants be inspected and that their eggs and egg products be wholesome, unadulterated, and truthfully labeled. So really what this means is, when we look at the word wholesome, all that means is that it is safe for human consumption. It's not going to make you sick. Unadulterated means that there is nothing that's been added to egg products that should not be there, or the consumer has not been told about, and truthfully labeled. Now, there's a lot of, labels as far as eggs go can be very sort of confusing these days because, there are certainly quality labels, but, nowadays with eggs you can get things like, cage-free eggs and pastured eggs and pasteurized eggs and all sorts of things. So sometimes the labeling can get a little bit murky because a lot of what you see on the egg cartons, there's no legal definition for certain terms. Although if something, if an egg, a hen is laying eggs in a cage-free environment, then that needs to be a cage-free environment. It may not specify that they're only cage-free for an hour a day. So there's a lot of sort of wiggle room in there, and labeling laws leave a lot of loopholes sometimes for the food supply. So, but as far as the Products Inspection Act goes, it doesn't have anything to do with the humane treatment of animals, and it really doesn't have anything to do, honestly, with the quality of the eggs, whether they're high quality or low quality. All it really means is that they are safe for human consumption, and that you are buying an actual egg product that is doesn't have anything added to it unless the label says so. And so by law, those are the only things that really have to be on there, and the only things that have to be true for that egg product. And that's because of this Egg Products Inspection Act of 1970. This law is enforced by the USDA Poultry Division and applies to all eggs, all eggs whether imported or shipped intra or interstate. Grading is something different. Grading is a quality measure. So remember, with the inspection, they just have to be safe to eat. Grading tells us what the quality of the eggs are. And we just talked about that a few slides ago with the US grade AA, grade A, and grade B. We know that in terms of quality, the AA performs the best. It's the highest quality. It's got the most thick egg white and good quality yolk, and it stands tall, and it's going to perform in recipes as it should. Candling is a method, and we talked about the germinal disc. One of the things that I talked about is the interior quality of the eggs is also looked at in the grading process. And in the picture here you can see the eggs running over a line that has lights underneath it. And so what it does is it lights up the inside of the eggs, and so either people or a computer can determine whether or not there is a darkening or dark spots inside of the egg that might indicate that that egg has been fertilized, or there's some other impurity or blood spots or things like that on the inside of the egg, and those eggs are removed. The reason it's called candling is because they did actually used to use candles for that process, but that is not the case anymore, but the name has stuck. Candling can also indicate the age of the egg by the size of the air cell. So we talked a little bit about the air cell when we were talking about the actual structure of eggs and what all of the different structures on the inside of the eggs are. And the air cell is something that develops because when an egg is laid by a hen, when that egg initially comes out of the hen, it is very warm. It's the same internal temperature as the hen's body, so it's a very warm thing. As the egg begins to cool down, what happens is the contents begin to settle. The protein molecules, everything else on cooling, they all start to slow down and settle. And that cooling causes that air cell to form. So it's because all of, again, as the inside of the egg is cooling down, there's a contraction happening, and that air cell happens. Now on a just laid egg, that air cell is going to be very small. And once that egg has cooled down, and there's been a contraction of the contents in the inside of the egg, it's still going to be a relatively small cell. But what we find is as eggs get older, because the shell of the egg is porous, there is an exchange of air and moisture with the outside. That egg loses moisture, loses that water because it vaporizes into the air. And less contents, less water, remember that egg is 75% water, less water means that that air cell is going to get larger and larger. So a very large air cell indicates that that egg has been around for a while. That's why some people say, you can tell a fresh egg from an older egg by putting it in water and seeing what floats. Well, the bigger that air cell is, the easier it's going to be for that egg to float. So if it's an older egg, it's more likely to float than if it's a fresher egg, and that's the reason why. If you've ever hard-boiled an egg and you peeled it and you notice that one end of the egg, the wider end of the egg has a really pronounced flat spot on it, you can be sure that that was an older egg. If the flat spot is smaller, then it was a fresher egg. And this is just a little more indication, a little more information on grading, and we talked about that in the previous slides. Again, big differences between the proportion of thick egg white to thin egg white and how tall the eggs stand. Grade A and double A are best for frying and poaching because they hold together very well. Again, these are the grades you're going to find primarily at the supermarkets. Grade B, again, not something you're going to find in the grocery store as a shell egg, but they generally do better in baking and cooking because the physical form of the egg when it's cooked doesn't really make that much difference. It's also important to note that the size of the egg has nothing to do with grading. Different hens are going to make eggs that are different sizes, and even despite the size, it may have very good quality or very poor quality. It just isn't a quality indicator. In general, there are about 6 weight classes of eggs, all the way from the jumbo, so the very, very largest hen eggs that weigh for about a dozen eggs 30 ounces, all the way down to the very smallest peewee size, which is 15 ounces for a dozen eggs. What you find in the grocery store most often are the large and extra large, and it's not uncommon to find the jumbo eggs. Most commonly, though, the large and the extra large is what you're going to find available at the grocery store, and what's most commonly commercially produced. Recipes, when they call for eggs, generally are referring to the large size, or the 24 ounce per dozen size. It doesn't say that, and if you use an extra large egg, generally it's not going to dramatically affect whatever recipe you're making. But again, one of those sort of unwritten rules of recipes, when it says egg, generally they're asking for the large size. Egg safety and handling. The FDA has designated shell eggs as a potentially hazardous food, and I think we've all probably heard this before. We know that consuming undercooked eggs is a potential health risk, and high-risk groups such as the elderly or small children or anybody who has compromised immune systems is advised not to eat eggs that are undercooked. Generally, what we're talking about, the pathogen that we're referring to when we talk about eggs most often is Salmonella enteritis. And as we'll see in the next slide, the majority of Salmonella cases that are reported are linked to eggs. But the interesting thing to make note of is right here on this slide, the chances of an egg being internally contaminated with Salmonella is relatively low. Less than 1 in 10,000 commercial eggs is going to be contaminated. If you recall earlier in the lecture, one of the things I talked about is how well protected an egg is from pathogens on the outside of the egg. And that's because those specialized proteins, those enzymes, really destroy any bacteria that would happen to get on the inside. There is an opportunity, however, for eggs to be internally contaminated if the hen herself has an infection, an ovarian infection of Salmonella that can be passed internally into the egg. This is very rare, but it can happen. As we go to the next slide, you'll see here that most commonly where Salmonella infection and contamination occurs with the egg is once the eggshell is breached. You break that shell open, you are destroying all of the protective layers that have been keeping the inside of that egg sterile. So contamination occurs more commonly during handling and preparation of the egg after it's been removed from its shell. The point that I was making in the previous slide is also on here. Raw or undercooked eggs and foods containing them have been implicated in about 80% of salmonellosis cases in which a food source was identified. So if you're going to get foodborne illness from eggs, it is much more likely to be Salmonella, but simple precautions in cooking with eggs and the very, very low chance that an egg is contaminated internally with Salmonella, it's not something it's not something that you're going to have a very big problem with unless you're somebody who comes from a high-risk group. That doesn't mean you don't need to be careful with eggs. You do. You need to be careful with any kind of food prep because certainly all foods are capable of transmitting foodborne illness. But I think this is probably a little bit more eye-opening that Salmonella inside of an egg is probably a little less common than you might have thought previously. To preserve egg quality and prevent foodborne illness, it's generally recommended that you buy eggs at a trusted retailer from refrigerated cases only. You may have seen eggs for sale, or maybe you've grown eggs yourself, raised your own hens for eggs, And you see that eggs are unrefrigerated sometimes. And eggs, because they are so well protected, they actually really don't need to be refrigerated for food safety reasons. The reasons that eggs are refrigerated at home and in commercial production is to protect the quality of the egg. One of the things about eggs is that they deteriorate much more quickly if they're not under refrigeration. Refrigeration helps to slow that down. So to really slow down that egg deterioration, if they are refrigerated around 40 to 45 degrees, that is optimal to keep them in good shape. Obviously, you want to buy clean eggs with uncracked shells. Anytime you've got a crack in the shell, you've breached that very sophisticated protection system that an egg has to keep itself bacteria free. Shell eggs, generally you want to use them within 3 to 5 weeks. Now, technically raw shell eggs have a much longer shelf life than 3 to 5 weeks in terms of food safety, but in terms of quality, after 5 weeks, you may find that those eggs are really not going to perform very well in any sort of food preparation. Do not eat raw eggs. So again, this is the salmonella issue. And if you've ever gone to a restaurant where they serve raw eggs in food preparations, anything from hollandaise sauce, Caesar salad dressing, eggnog, poached eggs, eggs Benedict, anything where the egg is undercooked, there's going to be a warning on the menu saying that people that are potentially higher risk for developing foodborne illness, the groups that I mentioned, pregnant women, it would be advisable to stay away from those things just because foodborne illness in those high-risk groups can be pretty, have some pretty bad outcomes. There are raw eggs that you can buy that have been pasteurized. It's a product that we have not typically seen in the grocery store, although it's becoming a little bit more common. It's something that in healthcare is a little bit easier to buy for healthcare food service. So what it means is that these eggs have been briefly heat treated to kill any pathogenic bacteria that might be on them or in them. And that actually makes them safe from a food safety standpoint to eat, even for high-risk groups. The problem with the pasteurized eggs is that the texture can be a little bit different. Pasteurization does denature some of the proteins, and so the texture of the egg might not be quite right, or might not perform in a recipe quite the way that you would expect that it would. But it is a product that's out there, and I'm thinking that we might begin seeing pasteurized eggs in the grocery store available for anybody relatively soon, if not already. It is going to be a higher cost, but some people are willing to pay that in order to stay safe. I'm going to switch from food safety to talking about eggs and food preparation. And at the beginning of the lecture, one of the things I mentioned was that eggs are capable of performing many different roles in food prep, and we're going to be coming back to that over and over again as we go through the remainder of the class. When we talk about cakes, we're going to be talking about the roles that eggs play. So here I'm going to start talking about some of these roles in a broad sense so that you can get a feel for all of the things that eggs are capable of doing. We're going to start by talking about giving a foam structure to cakes and meringues. We're going to talk a lot more about this as we go. We're going to talk about beating egg whites into foam and what foam actually does when we're making different types of cakes. Thickening custards and puddings. Egg yolks in particular, when combined with milk or cream forms something that in French cooking is called a liaison. And that's just spelled Liason, liaison. And what it is, it's just a thickener. So cream and egg yolk mixed together, mixed into a custard or a sauce, is a really good thickening agent. And it's also the basis of making custard from scratch, if you've ever done that. It adds color. Yellow color in foods that contain egg many times is because of the egg yolk. So yellow cake, egg noodles, custards, they all have that really nice yellow color. Eggnog, that's due directly to the color of the yolk. We talked about in the fats lecture, we talked about how the egg yolk itself is a good emulsifier. So the egg yolk performs that duty in emulsified sauces such as mayonnaise and hollandaise. In years past, things like souffles have been sort of in culinary vogue. We don't see those quite as commonly anymore, but essentially what a souffle is a sauce, usually a milk-based sauce, that is mixed with an egg foam, which is made from the egg whites, mixed together and then baked until it puffs up. So it's sort of like this really big, sort of puffy confection. It can be savory or sweet. You could make a chocolate souffle or a cheese souffle, anything in between. It's a very French dish. But in the case of the souffles, it's acting as a leavener. And one of the things we're going to talk about a little bit more in this lecture is that when you whip egg whites, not the egg yolk, but the egg white alone, it turns into a very foamy sort of stuff. It looks a lot like shaving cream almost. It's very puffy, it's very fluffy. And what's happening is when you beat egg whites are really, really good at incorporating air bubbles. So it looks almost like a big bunch of soap bubbles. And when you bake that structure, that foamy structure, it sets it. Anytime you apply heat to protein, and we talked about the egg whites being protein primarily, anytime you heat proteins, they denature, they coagulate, they thicken, and they hold their form. So if you are thickening a foam, an egg white foam that has trapped a bunch of air in it, you're really freezing that foam structure in place and adding air. And anytime you add air to a dish, it leavens it. To leaven means to lighten. So you're lightening up a recipe by incorporating air into it. Raises it up. We're going to talk a lot more about leaveners when we get to the cake lecture. But eggs, in this capacity of just using whipped egg whites, add air and lightness and fluffiness to recipes such as souffles. And popovers are another recipe where we see that leavening. Popovers are sort of like puffy bread that has a big hole in it from the leavening agent. Binding ingredients. If you've ever made a meatloaf, you've probably used egg. Egg is a binder. So what happens is egg is really good at acting as sort of a glue. You can stick a bunch of stuff together. When you cook a meatloaf, you've got ground beef, maybe some onions, some other ingredients that are in there, some spices, some herbs. You put some egg in there, maybe add some breadcrumbs, you sort of smash it all together, and then you heat it up. The heat denatures the egg protein, locks everything in place, and it keeps everything in a nice loaf shape. It's really acted as sort of a glue. Eggs can also act, continuing that sort of that glue role, if you've ever made any sort of a breaded chicken, for example. Many times you'll have like a fried chicken. You might have some sort of a an egg wash where the chicken is dipped in egg, it's dipped in flour, it's dipped in some sort of a coating and then fried. Egg is really good at gluing food together, so it's sort of an edible food glue. It can be used for glazing. If you've ever made bread or rolls, sometimes you'll be asked to whip together a little bit of egg with some water and then brush it over the bread or the pastry. And the heat hitting that egg protein browns it up and adds sort of a nice crispy golden crust that really enhances the appearance of foods. Clarifying liquids for soups, this is something that is a little bit more of an older technique, but in classic French cooking, one of the things that chefs would do is they would have a broth soup, which has been also referred to as a consommé. Consommes are generally some sort of a meat stock or broth, maybe chicken or beef or fish or something like that. And to clarify, what chefs would do is they would get, say for beef broth, they would get a little bit of ground beef, mix some whipped egg into it and some other ingredients, and they just sort of let this mass of egg and meat float around on the top of the broth. And what it does is it attracts impurities that are floating around in the stock. So you let this mass, it's also referred to as a raft, R-A-F-T, just like a raft you would put on the river. It's referred to as a raft, and if you leave it in there long enough, it attracts all the impurities. You take the raft out and you discard it, and it leaves behind this absolutely crystal clear consommé soup. And that's something that eggs have been used for in the past. Again, not so much anymore, but in the heights of classic French cooking, that was a very common technique. This is a table that just has a little bit more of the functions of eggs spelled out here. They add color, flavor, nutrition. We talked about eggs being very good source of high quality protein. When you have high quality protein in your diet, it helps restore your tissues and build muscle. Foaming, coagulation, color, inhibition of crystals. We'll talk about that a little bit more as we go on through the course. Right now, I just want you to have an appreciation for all of the different things that eggs can do. And a lot of this is because you can use the egg together as a single component, or you can separate it out and use the egg white and the egg yolk separately. And because they're just so incredibly different in their chemical structure, they just do very, very different things. So we're going to talk a little bit more about coagulation. Coagulation, again, is the thickening of the protein in eggs. It's also the denaturation of the protein. And if we go back to what the protein molecule looks like, we're going to talk more about this as we go through, but for right now, what I want you to think about as far as the protein molecule is that it's sort of a globular kind of molecule. And when you denature it, you change the shape of it. And when you change the shape of it, it thickens, it coagulates, and it eventually just sets into a new structure. So it's sort of like almost spraying hairspray on hair. Your hair is free flowing, you spray some hairspray on it, and it's sort of frozen and locked in a particular position. So this is what happens when egg whites are beaten. So, the thing about egg white foam is that it is a great component for many different types of recipes. I talked about cakes already, I talked about popovers, I talked about the souffles. If you've ever made meringue, this is a major component of making a meringue. As egg whites are beaten with a mechanical beater, as you see in the pictures, they go through many different stages. They become very foamy at first. And you can see in that top picture there are a few bubbles forming, but it doesn't necessarily look like foam. As you continue to beat it, you form very soft, moist peaks. And if you continue to beat it, they become moderately stiff and will actually stand up. When you pull the beaters straight up, you'll get peaks that stand up, and you can see that in the bottom photo there. It's almost the same texture as shaving cream. So when I have students who are beating egg whites, I tell them, if they're looking for a stiff peak stage, to continue until it really looks like shaving cream. Many times recipes that have you beat egg whites will tell you what stage you're looking for. Soft peaks, you're going to, so the second picture there, you're going to beat until you lift the beaters up, and there are very small sort of peaks that form, but they don't stay up very long. They sort of just fall back into the rest of the egg white foam there. They're not extremely thickened yet. So depending on what it is that you're making is going to dictate how stiff you want that foam to be. Overbeating will cause the egg white foam to break, and I have a picture of that coming up, but it looks like sort of lumpy shaving cream, I guess, for lack of a better descriptive term. And if egg whites have been overbeaten, they will not work in recipes because they don't mix in smoothly. And one of the things that you're doing by beating your egg whites is you're incorporating air. That's why things foam up. You're also denaturing the egg white protein. So that physical beating of the egg white changes the structure of the protein molecule. It unwinds it, it denatures it, and it freezes it into a new position. And actually, in the case of foam, what's happening is the structure of the protein molecules is being lined up around air cells. So you're denaturing the protein and sort of whipping it into almost circular shapes to strengthen those foam cells that are being made by the whipping process. And that's something that you want if you are using your egg whites as a leavener. You want that protein to protect those air cells because it makes the foam more stable. So it's going to make your cake, your angel food cake, stand up better. It's going to make your souffle stand up better. If you overbeat the foam, what happens is you've gotten to a point where that protein has lined up and is protecting the air cells. But if you continue beating, what happens is you're going to destroy all those air cells and destroy the foam. So you take it a step too far and it doesn't look right. Whenever you're beating egg whites, you always want to make sure that they have a sort of glossy, wet appearance to them. They're shiny. If you beat those egg whites past the point where they're shiny, you've overbeaten them and you've started to break down those air cells. So no matter of extra beating is going to bring those whites back to be able to put in your cake or in your lemon meringue pie. It's just not going to work. In this slide, you can see what the overbeaten egg whites look like. They're sort of what we refer to as flocculated, which means that they're sort of no longer a cohesive mass. They're just sort of in little pieces, and it looks almost lumpy. This picture, it's hard to tell, but if you were to look closely, you would see that there is no longer any gloss on the surface of these beaten egg whites. They're actually going to appear very dry. And as I mentioned, this particular mass of egg whites would just not mix very smoothly into whatever it is that you were trying to add them to, which of course would be detrimental to the end dish. This slide is really the written form of what I mentioned in the previous slides about the denaturation of protein from mechanically beating egg whites and the resulting air cells. So you can look this over for written representation of what I just said. We're going to turn our attention to physical factors that affect the quality of mechanical beating of egg whites. And so for this part of the discussion, we are referring primarily to egg whites and the resulting foam. We talked early in the lecture about the different parts of the egg and how changes in the egg occur depending on how old the egg is. And one of the things that we know for egg white foam, to get really, really good quality foam, you need an egg that has a higher proportion of thick egg white, which essentially means a fresher egg. This is one of those things that recipes don't tell you. So if you are making an angel food cake that relies very, very heavily on egg white foam for the structure and for it to turn out correctly, if you're using older eggs, you're never going to get the amount of high quality foam that you would if you're using very fresh eggs. Thick egg whites produce a much more stable foam than the thinner egg whites do, and so it's just going to perform better in your recipes. Also, eggs at room temperature but more easily, quickly into a larger volume. So you may have seen recipes in the past where they tell you to make sure your eggs are at room temperature before you cook with them. Well, if you're making a foam, that's the reason why. You're going to get better high quality foam if those eggs are room temperature rather than being just pulled out of the refrigerator. One of the things about whipping egg whites is that you have to absolutely positively be sure that there is no fat contamination, or you are not going to get any significant egg white foam. So what that means is that when eggs are separated, you have to do that very cleanly and make sure that none of the egg yolk gets in with the egg white. Because if that happens, again, you're not going to get good egg white foam. The other thing is paying attention to the vessel that you're doing the whipping in. If you choose something like plastic, a plastic bowl for example, to try to whip a good egg white in, usually it's not going to work, and that is because plastic is really good at absorbing materials that have been in the bowl previous, and so if there's any trace of fat left in that bowl, within the walls of the bowl, you're not going to get very good foam. So generally when you're whipping egg whites, you want to make sure that you're doing so in a non-porous vessel. So something like glass. Traditionally what's used is a copper bowl. Copper really helps stabilize that egg white foam and make it stronger. You just need to be very, very careful about any kind of fat contamination. The other thing to be careful is the size of the bowl has to be adapted to the amount of egg to be beaten. If you have a single egg white, that's not really a whole lot, but when you start beating it and incorporating air, it's going to grow. So you need to make sure that your bowl is big enough to accommodate that. Also, the type of beater is important. There are beaters out there that have very thick blades, as you can see in the picture here, and then there are others that have thinner blades, like a wire whisk. The end result you're going to get with the different types of beaters is really the same, but it's going to take longer to get to a very fine walled foam that is having those air cells, lots of air, very small air cells with the denatured protein around them. It's going to take much longer to get to that situation with the very thin blades, because it's just going to take longer for the beating to happen. But the end result is that you're going to get there. It's just going to take longer with one or the other. There are different effects on egg foam depending on different substances that are added to it. We talked about added fat retarding foam formation, and you can see it doesn't take very much. 0.5% concentration of fat in that egg white foam will prevent the foam formation from happening. Salt is another thing. If salt is added to those egg whites, you're going to drastically reduce the amount of air cells that you're able to make. You're not going to have a very high volume. And in terms of recipes, you're really not going to find recipes that are going to ask you to add salt to egg whites that are going to be beaten up into a foam. It's much more common to find sugar as an additive. Acids will help decrease the stability of the foam, and one of the ones that is used very commonly to help protect the foam and for whatever its use is going to be is something called cream of tartar. And cream of tartar is a sort of white powder. It's actually a byproduct of winemaking. And traditionally it was a sort of white coating that would happen on the inside of wine barrels, and comes from the grapes, and they would scrape that off and found that it really helps stabilize egg white foam. And so you can buy it commercially for that process as well. Generally, if you're going to add cream of tartar, you want to add it just before or shortly after your foaming has started, and that's when it does its best work. Sugar is something that, as you see there, will increase the beating time. It's going to take longer for you to get your foam, but it is something that will help stabilize the egg white foam. It's important not to add the sugar before the beating gets started, because it can take much longer to get that foam going if it's added right away. What you want to do is wait until the foaming has started, then add your sugar and continue the beating process. It will take longer, but it's not going to retard the foam from happening. This is a really common step if you're making a sweet souffle, or if you're making a cake batter that's going to require the leavening effect of the egg white foam. You're going to have sugar in there to kind of sweeten things up and to pull those flavors out. We could talk briefly about using egg yolks and beating egg yolks. Egg yolks, because they're primarily fat, they don't have that same molecular structure that's going to allow great foaming to happen. However, you will come across recipes that ask you to beat egg yolks. And while you're not going to get the same volume that you would get by whipping egg whites, you do get some increase in volume, because again, anytime you mechanically beat something, you're incorporating air into it. And so in that way, egg yolks could be used as a bit of a leavener. Anytime you get that extra air in there, it will help leaven whatever you're going to put it in. Many times, well actually all the time, when you beat egg yolks, you're going to get a bit of a change in color. It's going to kind of pale out a little bit, so you'll get sort of a lemony color. And as I mentioned before, this color is something that adds color to the foods that it becomes part of. So that yellow cake, custard, egg noodles, eggnog, get that sort of bright, sunny, lemony color from the egg yolks. We're going to talk a bit about the preparation of eggs themselves as a food. So not so much as an ingredient in another recipe, but actually as food to be eaten separately on their own. And we've talked about mechanical coagulation of egg proteins with the beating in the egg white foams. Heat is another thing that causes that coagulation to happen. So you put eggs into a pan, you heat it up, and that egg white turns from that sort of see-through egg white into an actual white mass. And when that happens, that means that those proteins are denaturing. They're uncoiling, they're reconfiguring themselves, and they're becoming much more firm. For egg whites, that happens at about 140 degrees. Those egg proteins begin to coagulate and harden. Egg yolk takes a little bit more heat. That happens at about 149 degrees. And that's why you can have sunny side up eggs with the yolk still runny, because the egg whites, they coagulate at a much lower temperature. Egg yolks take a little bit longer. A whole egg, on the other hand, if you were to scramble those two together and cook them up, the whole egg will begin to coagulate at 158 degrees. So higher than both of them once you mix the two together. There are certain ingredients that when they're added to eggs will actually change these coagulation temperatures. So it's something to be aware of when you're using eggs in recipes, and there may even be directives in recipes that will incorporate these techniques as well. Some ingredients such as milk or sugar increases the coagulation temperature. So if you're making scrambled eggs and you add, say, milk or cream to it to kind of make it a little bit more tender, it's going to require more than 158 degrees to coagulate and set that entire egg mass. On the other hand, if you add salt to your eggs, your scrambled eggs, you're going to have them coagulate at a lower temperature than 158, because that salt hastens the coagulation process. The key to cooking eggs is to keep the temperature relatively low and the cooking time short. One of the rules of thumb about cooking eggs that I always remember is to keep cooking low and slow. You don't want to be in a rush when you're cooking eggs, because if you heat them too rapidly and too high, they will become crusty on the bottom of the pan, or they'll burn, and neither of those is pleasant. Or the other thing is that they'll get very dried out, and dried eggs are just not real pleasant to eat. If you keep the heat relatively low, so if you're cooking scrambled eggs, you want to cook them over, say, medium-low to medium heat. I wouldn't go any higher than that, and then take your time and cook them. They will reward you by being very moist and having lots of flavor and not being all dried out. The other thing that I think a lot of people don't understand about cooking eggs, hard-boiled eggs, is that they cook the eggs at a much too high temperature, and they cook them for too long. If you've ever had the experience of opening up a hard-boiled egg to find that there's sort of a greenish ring around the egg yolk, or the egg yolk itself is sort of a greenish color, that's actually because of a chemical reaction that occurs between sulfur and iron in the egg white and the egg yolk, respectively, due to overheating. So if you can keep the hard boiling of the egg to a minimum time, it actually can really help prevent that from happening. One of the best ways to do that is when you've got your eggs in the pan. First of all, you don't actually want to ever boil your eggs, because if you do that, one of the things that happens is a boiling can agitate the eggs quite a bit, causing them to bump into each other and potentially crack while you are cooking them, and that's going to ruin your egg. So actually what you really want to do is kind of keep them at kind of a high simmer and get them up there, let them simmer for maybe about 20 minutes or so, and then you turn the heat off and you let them sit in the water and continue to cook. and after letting them sit for a time, maybe another 20 to 30 minutes, you can actually pull them out and they should be okay. Maillard-Browning reactions are something else that happens in the egg. We're going to talk a lot more about that when we get to the cake lecture, so I'll talk more about that then.